Hello everyone, I Pratiksha along with Vishakha will be presenting our topic, the real-time operating systems. Overview of the presentation will include about the operating system, the basic architecture, modes, definition of the operating system, categories, structure, characteristics, functions, scheduling algorithms and applications. What is an operating system? An OS is a program that, after being initially loaded into the computer by a boot program, manages all the other programs in a computer. Operating system facilitates essential services provided by a kernel understanding hardware resources available interacting with processes. Everything in an OS is a process, including the operating system itself. This slide shows us the basic OS architecture. The standard OS model includes software and hardware. Software has the applications and operating systems. Hardware includes CPU, RAM, and the input-output peripherals. There are various modes of operation of operating system like batch, multi-programming, multitasking, and the real-time system. In batch, each processes are bundled into batches. Multi-programming, where each program runs parallelly and concurrently. Multitasking, each program interacts with itself and other programs. Real-time system, where essential feature is time and each task is time critical. What is real-time operating system? Real-time operating system is a variant of OS that operates in constrained environment in which computer memory and processing power is limited. RTOS provides services in definite amount of time. A task is completed within specified time delay. RTOS is intended to serve real-time applications which process data as it comes in, typically without buffer delays. A key characteristic of RTOS is the level of its consistency concerning the amount of time it takes to accept and complete an application's task. Some examples of RTOS are controlling traffic signal, nuclear reactors, spacecrafts, and an HDTV receiver. Let's explain the HDTV receiver. Now it needs to read a digital signal, decode it, and display it as the data comes in. Any delay would be noticeable as jerky or pixelated video or audio will occur. Question occurs, why RTOS? RTOS is basically necessary for the following things: resource management, scheduling, hardware memory protection to isolate applications. Resource management is the primary operation of real-time operating system. It lets resources share a system. It also avoids resource leaks and resource contention. Resource leaks is an act of refusing a resource, and contention is when multiple processes wish to access a limited resource. Scheduling. Scheduling is the procedure of selecting processes from the queue and loading them into main memory for execution. There are different scheduling algorithms which will be discussed further. Hardware memory protection to isolate applications. RTOS was developed so that embedded developers could ensure their applications met highest possible requirements for security, reliability, and performance. RTOS uses hardware memory protection to isolate and protect their applications. Design principles of RTOS. The most common designs are event-driven and time-sharing. In event-driven, tasks are switched only when an event of higher priority needs servicing, called preemptive priority or priority scheduling. Time sharing. In this, tasks are switched on a regular clocked interrupt and on events called round robin. Time sharing designs switch tasks more often than strictly needed but give smoother multitasking, giving the illusion that a process or a user has sole use of machines. Real-time operating system is classified into two categories: hard real-time system and soft real-time system. In hard real-time system, There are time critical deadlines that must be met, else a catastrophic system failure may occur. Examples are air traffic control and nuclear power plant. Soft real-time system. Soft real-time system are not catastrophic if deadlines are missed occasionally, although they are undesirable. They are also called as best effort systems. Examples are multimedia transmission and reception, websites and services, computer games. Now I would like to hand over the presentation to Vishakha. Thank you.
So this diagram shows the structure of real-time operating system. It is basically divided into three layers. The first layer is the applications layer, which is used by the end users. The second layer is the real-time operating system kernel and the boot support packages. Real-time operating system kernel consists of timer, which is the main component of the RTOS kernel. Timer is a software entity derived from the hardware clock, which provides a mechanism that helps in synchronization of the tasks in bounded fashion. This layer interacts with user through applications and works on the hardware level. The final layer is the custom hardware layer where the operating system is going to run. It might be Linux, Android, Windows, etc. This is the basic architecture of real-time operating system. So considering the real-time applications, there are different tasks like time critical input output, monitoring, network communications, etc. that interacts with the real-time operating system. Scheduling, memory management, user interface, file management, etc. are the main functions of real-time operating system. The hardware peripherals and microprocessor, also microcontroller, are the supporting components that help in the overall operations of the system. Now let us look up through important characteristics of real-time operating system. They include consistency, reliability, scalability, performance, predictability. Consistency is the amount of time a system takes to accept and complete a task. Reliability states that a system should operate for longer period of time without human intervention. Scalability. A system should be flexible enough to adapt to application-specific requirements. Performance. It is the quality of execution of a system. Predictability. It is the ability of the system to predict itself in any given situation of the task. Functions of RTOS are task or process management. When we boot our PC, there are certain processes already running. For example, Alt plus Control plus Delete. When we press this, there are processes which are managed by the kernel. Memory management. In this, hard disks, RAM, these are managed by the kernel. File management. It keeps a track of where and how files are stored and maintains a log of file usage. Resource allocation. Management and utilization of resources is taken care of. Interrupt handling. Task allocation is performed on the occurrence of interrupts. Scheduling. Controlling and optimizing resources and its utilization is handled. Interprocess communication. It manages interaction between one or more processes. Memory allocation is more critical in real-time operating system than in any other operating system. First, for stability, there cannot be memory leaks. Memory leaks, that means memory that is allocated, then unused but never freed. The device should work indefinitely without ever needing a reboot. For this reason, dynamic memory allocation is frowned upon. Whenever possible, all required memory allocation is specified statically at compile time. Scheduling is an important function of real-time operating system. There are various scheduling algorithms. The first one is priority-based scheduling. This schedules the threads based on their priority. First ready thread with highest priority is executed first. If more threads of same priority are ready at the same time, they are scheduled as per first in first out manner. For example, consider three processes P0, P2 and P5. Their order would be P5, P2 and P0. 0 is considered lowest and higher number is the highest. The second one is clock driven scheduling. All the parameters known in advance, that is, release time and execution time, is already known before scheduling occurs. Here, there is a minimal runtime overhead, but not suitable for many applications. The next scheduling algorithm is round robin scheduling. In this, the execution is done as per first in first out order. The next ready thread is executed after completing the current ready thread. Here, the time quantum is given to the jobs. For example, the application in high-speed switching network uses round-robin scheduling algorithm. Like every other system, a real-time operating system also has some advantages and disadvantages. The advantages are maximum consumption. Real-time operating system gives maximum consumption of the system and gives us more output while using all the resources and keeping all the devices active. There is little or no downtime in these systems. So it can be also used by the servers that are hosted to give maximum output of hosting companies. Task shifting. There is a very little time assigned to shifting tasks in these systems. For example, in older systems, it takes about 10 microseconds in shifting one task to another, and in latest systems, it takes 3 microseconds. Focus on application. These type of operating systems focus on applications which are running and usually give less importance to other applications residing in waiting stage of life cycle. So less applications or tasks are managed and give exact result on current execution work. Real-time operating system and embedded system. Due to small size of programs, real-time operating system can also be used in embedded systems like in transport and others. Error-free. Real-time operating system is error-free, that means it has no chances of error in performing tasks. The disadvantages of real-time operating systems include limited tasks. There are only limited tasks that run at the same time, and the concentration of these systems are on few applications to avoid errors, and other tasks have to wait. Sometimes there is no time limit of how much the waiting tasks have to wait. Use of heavy system resources. Real-time operating system use a lot of system resources which is not as good and are also expensive. Low multitasking. Multitasking is done few of times, and this is the main disadvantage of real-time operating system because these systems run few tasks and stay focused on them. So it is not the best for systems that use a lot of multi-threading because of poor thread priority. Complex algorithms. Real-time operating systems use complex algorithms to achieve a desired output, and it is very difficult to write such algorithms for a programmer. Device driver and interrupt signals. Real-time operating system must need specific device drivers and interrupt signals to respond fast to interrupts. Thread priority. Thread priority is not good in real-time systems since they can do only lesser switching of tasks. Expensive. Real-time operating systems are usually very expensive because of the resources they require to work. Not easy to program. The real-time operating systems are not that easy for a programmer to write a proficient program for them. Here are some applications of real-time operating system. They include modern telecommunication systems, radar systems, satellite monitoring, strategic and military operations, guided missile landing units, etc. So now I would like to conclude this presentation by saying that the real-time operating system has been a hero in many applications like fuel injection system, nuclear reactor control, satellite control, and fully equipped warfare aircrafts. And I still feel that the best is yet to come. For this topic, we have referred Google.com, Wikipedia, YouTube, and the book Operating System Concepts. Finally, we would like to thank each one of you for taking out time and watching this presentation.